Okay. So, first of all, I have to apologize. Okay. Um, on Friday we had a quiz. I sent the quiz through email, and it wasn't until after that day I realized that I'd sent the wrong version of that quiz out, and the version I sent out was the one that had the answers on it. So I can't, in good faith, take that as a quiz grade, but I don't want to punish people who did the work on there, so I'm going to be taking the quiz as an extra credit grade. Okay, but to make up for it and to make sure that I still know how well y'all are doing on the current content, I'm going to be giving basically the same quiz this week on Friday. There'll be a few changes to it. There'll be a little bit of new content on it, but it's going to be mostly the same quiz. Okay, and that's again because I want to make sure that I understand how y'all are doing. Okay. So, what is the last thing that Mr. Mrzinski covered? I think y'all just had that test, right? Polynomials? Okay, good. Okay. Yeah, I figured. So the test was on Saturday, correct? Okay, so that test, I hope my review worked for y'all and helped y'all study for it. Well, let's get into some new stuff. Okay, so polynomials. We've been talking about adding, subtracting, multiplying, dividing, powers, roots. We've officially gotten through all of our operations. Okay? Now we can start putting these operations to use for us. So what I have told you in the past is that we have two basic types of terms or things that we deal with in algebra, that being expressions and equations. Okay, so an expression can be anything. It can be 55. It's a perfectly fine expression. It can be x plus 2. It can be x cubed. It can be square root of 2 plus 3, okay? All of these are perfectly fine expressions. But there is a subset of expressions called polynomials. So if we break down that name, polynomial, there are two parts. Poly means many or more than one. And nomial means number. Okay? So something like 55, that's a single number, that's a single value. Okay? But something like x plus 2, we have two different types of numbers here, two different terms. And they're not like terms. We have x and we have 2. This is a polynomial. X to the third. It's a single thing. In fact, square root of 2 plus 3, still just a single number. We could, in theory, add square root of 2 and 3. They're basically like terms. It's when we get into things like x and y or maybe even x squared. It's when we start having things that are non-like terms that we start having polynomials. Okay, and again, that means many numbers or more than one number. So each of these has more than one type of number inside of it. We can further subdivide polynomials into binomials, trinomials, quadrinomials, pentanomials. All of those prefixes, like binomial, bi meaning two, nomial meaning number, trinomial, tri meaning three, nomial meaning number. So it's two numbers, or three numbers, or four numbers, or five numbers, so on and so forth. So like this one right here, we have x, y, and 3, negative 3. We can't combine them. These are three different types of terms. This would be a trinomial. This one down here, we have two different types of terms. This one would be called a binomial. But they all fall under the classification of a polynomial. Okay? Now then, it's important to remember something. There is a very big difference between this and this. X and y, if we have x plus y, we cannot add x and y. They are not like terms. X times y works. We don't need like terms to multiply or divide things. This is two numbers. This is one number. This is one value. Okay? So we could even have something like x squared y plus x. This is one value right here. This is another value. This is a polynomial. So the things that you're going to see that separate different types of numbers are add and subtract. That's what you need to be looking for when you want to determine whether something is a polynomial or a single value. Does that make sense? Any questions? And remember, people in the live stream here, if you want to ask questions, you can type it into the chat. Okay. Now, there are some things that we need to keep in mind when we're working with polynomials. First of all, big one, really big one. If we have x squared, that's x times x, right? Easy to understand. Okay. If we have xy squared, okay, really what we're doing here is we're raising a power to another power, right? Because we understand that x has an imaginary 1, y has an imaginary 1. So when we raise this power to a new power, what do we get? X to the second, y to the second. So I think I mentioned it in this class. This is what we're used to seeing right now. And what we're thinking right now is, oh, that exponent distributes. It does not. If we have x plus y, now a polynomial, not a single number like this is, not a single number like this is, now two numbers. Remember that really what we're doing when we square something is we are multiplying it by itself. So this would be xy times xy, which would give us x squared y squared. This would be x times x, which would give us x squared. This here, you need to remember, it is x plus y times x plus y. And it is not going to come out to x squared plus y squared. In fact, let's see what this comes out to be. Now, when we have numbers right next to each other, we multiply, right? And we have parentheses here. So when we multiply, we're going to distribute. When we distribute like this, where we have more than one number, we will distribute the first number into the set of parentheses. So it's x times x. X squared. Then x times y is what? Is what? X times a y. xy. Okay? So once we've distributed this first number, we will then distribute the second number. Y times x. xy. Y times y. Y squared. And then we simplify this. Oops, this should be x squared. So we simplify this. We don't have any parentheses. We have exponents, but we can't do anything with them. We don't have any multiply. We don't have any divide. We have add and subtract. We have like terms here. X, y, and xy are like terms. So if we combine them, all together we get x squared plus 2xy plus y squared. This is the answer you're looking for. Again, powers do not distribute. What in the world? How is that even possible? Okay, somebody in the stream brought something up. There's a bug going on. Yeah. Basically, the thing that lets them see this is just crashed. Okay, so that should be back up any moment now. There we go. All right. So sorry about that for y'all in the chat. Okay. So what I was saying is that we have monomials, which are just a single number, and polynomials, which are more than one number. So we cannot treat polynomials the same way that we treat monomials. So like for here, if we look at this, we're used to thinking that this distributes. That's really not what's going on there. Really, this is xy times xy, so they go to x squared, y squared. we can't do the same thing here. We can't just say x squared plus y squared. We have to remember that what we're doing here is we are multiplying this term by itself. So x plus y times x plus y. Okay? So once we multiply all that out, we get this. I'm about to give us another example of this though. So any questions before we move on to another example? None? Make sense? Okay. So let's try this. X plus 2 squared. Again, we cannot think of this as being distributing that power. We need to actually multiply this out. So this is x plus 2 times itself, squared, x plus 2. Okay, and once again, the way we multiply this is we take that first number, distribute it. So x into this set of parentheses. So what is x times x? X squared. What is x times 2? 2x. Okay, so we've got the first number done. Now we do the same thing with the second number. What is 2 times x? Plus 2x. And 2 times 2? 4. So now we need to combine any like terms we may have. Do we have like terms? 2x and 2x. So if we combine them, how many do we have? 4x. So altogether, this is x squared plus 4x plus 4. And this is what you should usually expect to see when you multiply these things together. You should multiply a binomial times a binomial and get a trinomial. Okay? So again, for sake of practice, I'm still broadcasting. Oh, there it goes. All right. There's some kind of internet problem going on today. All right, so where were we? Okay, we've done x, so now we need to distribute 1. So 1 times x is what? X, or just 1x. 1 times negative 2? What? 1 times negative 2? Negative 2. 1 times anything is that thing. Okay. So now, do we have any like terms? Which ones? We do. Nope, x squared and x aren't like terms. They have to have the same power on them.
Oh, the x.
Yes, negative 2x and x are both like terms. They're both in terms of x. So negative 2x and x make us negative 1x. So we get x squared minus x minus 2. Again, we multiplied two binomials and we got a trinomial. And like I said, that is what you can usually expect out of these things. You multiply two binomials, you get a trinomial. Any questions? None? Okay. But I keep saying, usually, that's what you can expect. There's one place that is not going to happen. And it's a pretty interesting and useful idea. Let's say we have x plus 3 times x minus 3. So, Do what? Not completely, but they are going to cancel in a certain spot. It's a good idea. I like that. So these are mostly the same, but what is different? What is the one thing that's different? The signs. So we have x and we have 3 in both of them, but one of them we have a positive 3, one of them we have a negative 3. So let's see what happens when we multiply these. So again, we need to multiply our first number. So what do we get when we multiply x? Next. Negative 3x, good. All right, now we need to multiply the 3 plus 3x. Three times negative 3? Negative 9. Okay. So now we need to combine our like terms. What like terms do we have? Negative 3x and positive 3x. Well, what happens when we combine them? Yeah, we get 0x, and 0 times anything is 0, so it cancels. So we're just left with x squared minus 9. This is the one place where you will multiply binomials and get a binomial. These are called conjugate binomials. And when we multiply conjugate binomials, we will get a difference of squares. So what do I mean by difference of squares? So look at both of these numbers. We have x squared and 9. Well, x squared is obviously a square. Is 9 a square of something? Is there something that times itself gets us 9? 3. So 9 is a square of 3. So both of these are squares, and another word for subtracting is to take a difference. So this is a difference of 2 squares. Does that make sense why we're calling it that? Okay. These are extremely important to us. And we might not get to it today, but we will definitely get to it on Wednesday. Any questions? Okay. What about multiplying a single number by a binomial, or a trinomial, or any polynomial? Well, that's very easy. We've already done that before. It's distribution, right? So what do we get? Perfect. 3x plus 12. Okay. So we can multiply binomials together. We can multiply a monomial by a binomial. What about a binomial times a trinomial? Yeah, sure. Again, it's just distribution, but we got to take it one step at a time. First, we distribute that x. So, x times x squared, what do we get? X cubed. X times negative 3x. Negative 3x squared. Good. All right, and then x times 1. Okay, so we've got the x part done. Now we need to do the 2. So 2 times x squared. 2 times negative 3x, and 2 times 1. Okay, so do we have any like terms? Yeah, we do. We actually have 2 pairs of them. We have a negative 3x squared here, and it pairs up with the positive 2x squared there. They're both x squareds. They're both like terms, so we can combine them. X and negative 6x are both in terms of x to the first. So they're like terms. We can combine them. So let's see what we get when we combine our like terms. Negative 3x squared and 2x squared. How many x's do we have? Negative 1. Or we could just say negative x. Doesn't matter. But those are taken care of. All right. X minus 6x. How many? Negative 5x. Those are taken care of. These other two didn't have anything to pair up with. Whoops, that should be squared. There we go. So this one, we multiplied a binomial by a trinomial, and we got quadrinomial, 4 terms. So if we multiply a monomial by a binomial, 1 times 2 is 2. If we multiply a binomial and a trinomial, or I should say a binomial and a binomial, we get 3. So 2 to 3. Then if we multiply a binomial by a trinomial, we get 4 terms. So as we increase the terms in our polynomials, the result also increases its terms. So once again, I'll show it to you one more time. Binomial times a binomial, we have 2 terms. Binomial times a binomial, we have 3 terms. So it's increased by 1. Binomial times a trinomial, 4 terms. It's increased by 1. And there is an idea behind this. And that is called degree. So when we look at a polynomial, it will have a degree to it. And the degree is the largest power present in that polynomial. So what power is the largest in this one? Cubed. So the degree for this one, exactly. What's the highest power in this one? Squared. So this one has a degree of 2. It's the highest one in this one. Squared. So again, a degree of 2. This degree allows us to understand a whole lot about the polynomial. Because we can have very wild polynomials, maybe something like x to the 7th plus 4x to the 5th plus, let's say 7x to the 2nd minus 2x plus 4. Now if we look at this, we'd say, okay, there's 1, 2, 3, 4, 5 terms. But the degree tells us, actually there's more terms than we think here. Again, the degree tells us a lot about this polynomial. Degree, what is the degree here? 7. Highest is 7. Now there's a lot of stuff that isn't stated in this polynomial because it doesn't need to be there. we have really x to the 7th. Then between that and 5, there's an x to the 6th. But it's 0x to the 6th. We have none of them. That's why we don't really write it down there. But it's important to remember that that term is technically there. Then between 5 and 2, we have a couple terms. 0x to the 4th, 0x to the 3rd. Then we get to our 7x squared. And then we have our single x, and then our constant. So this degree tells us how many powers are actually present here. We should have 7 numbers with powers on them. Okay? It's just that some of these are not really useful in the overall polynomial. 0x to the 6th, it's just 0, and it doesn't affect it. But it is important to remember that these things are present. And again, we'll see why on Wednesday. Along with degree, actually there's one more thing I want to point out about degree. Let's look at this. Remember that we can have something like x squared y to the 3rd, and that's a single value. So if we then say something like plus x y to the 7th, maybe minus x to the 3rd, y to the 4th, which one is our degree? Well, we might say 7, because 7's pretty high. But we have to think about the overall degree of the value. Each of these has an overall degree. So yeah, we might say 7, whoops. Let's change that back. We might say 7, because it's pretty tall and pretty high, but there's also a power on this one, and it's part of the same number. What power is on x on here? 1. So really the overall here is 8. Okay, so what's the overall power here? 7. What's the overall power here? Not 6. 5. So the actual highest power is 8. So the degree for this polynomial is 8. Any questions? None? Makes sense? All right. One more thing. Polynomials have a structure to them, and it's a structure that we like to follow. So maybe I've got 5x squared minus 7x to the 4th plus x to the 3rd minus 2x to the 7th. Okay? So again, they have a particular structure to them. First of all, we like to have that number with the largest power, the thing that has the degree on it, to be in front, and then everything to descend in power from there. So if we were to reorganize this thing, we see that the highest power is 7, so we have negative 2x to the 7th out in front. Next, in descending power from that, is negative 7x to the 4th. Next, we have x to the 3rd and then next we have 5x to the second. Again, descending power. And when we arrange it like this, there's another important piece that we need to look at, and it's this number right here. The number out in front of a variable, remember, is called a coefficient. And when we're talking about polynomials, the coefficient that goes along with this power, or this degree, is called our leading coefficient, because it is literally the one leading the entire polynomial. It's out in front. Okay? Why am I stressing these so much? It's because leading coefficients and degrees can really help us break these things down. This is a very complex polynomial. It's got a lot of stuff going on in it. Now, if I could break this apart somehow and make it simpler, it'd make it a lot easier to do some more math with it. I'll give you an example. Let's say I've got x squared plus 4x plus 4. As this thing is right now, it's kind of complex. Okay? However, I can do some magic with it. And let's see, my leading coefficient is 1, so all I need to do now is there. What I just did is I took this thing, this polynomial, and broke it into factors. Again, factors are things that will multiply to get the original. If we were to multiply x plus 2 and x plus 2 together, we would get x squared plus 4x plus 4. These are exactly the same. They are equal to each other. But this one is in simpler form. And again, it being simpler like that allows us to do some more processes. But the idea behind this is factoring, and that's what we're going to be getting into on Wednesday. Understanding how to go from these complex structures to much more simple, broken up numbers. Okay? Any questions? All right. So that'll do it for today. Again, quiz on Friday, but Wednesday we're just going to keep on going with this factoring thing. So I hope you have a good day, and I'll see you all on Wednesday.